Good afternoon, everybody. Good afternoon, everybody.
Good afternoon.
Good afternoon, Professor.
Good afternoon, Professor.
Good afternoon. You guys see my screen? Can you guys see the screen shared?
Yeah.
All right, so we're going to continue today with the equations and lines that you started last time with the other professor. Today we're going to talk about a new notion or concept, which is the slope. Okay, going to talk about the slope, and we're going to see what it is and how to calculate it. Then we're going to introduce another formula called the slope-intercept form, which we use for lines, which we can use easily to get the slope and also graph lines. So let's start with the definition of the slope first. So slope is basically when you have two lines, for example, this line, another line like that. We notice that one line, this one, is steeper than the other. This one kind of is more slant or kind of goes up quicker or faster, but is closer to the vertical y-axis as opposed to this one. So this one we say is steeper than this, just like a hill or a flight of stairs. Sometimes it's steeper than some are steeper than the others, just like this. If you imagine this as a hill or a flight of stairs, it looks like it's harder to climb than this one. We say it's steeper. Okay, so if we call this line 1 and call this line 2, you can say that line 2 is steeper than line 1. Okay, so what the slope is basically the measure of the steepness. So each one of these has its own slope. The symbol for slope is m. Okay, the slope for slope symbol is m. For some reason, it's always called that. Each line has its own slope. So this line has its slope, let's say m1. This one has its slope m2. Just by looking at it, we can say that, again, this line is steeper than this line. Therefore, the the slope of this line m2 is higher than slope of line 1. Okay, so sometimes we could say the absolute value of the slope of this line is higher than the absolute value of this one. So that's basically what the slope is. It's just a measure of the steepness of a line. Okay, let's write it down. The slope, let's say, is a measure or measures the steepness of a line. Okay, so that's the definition. So it's a quantity, it's a numerical value that we can actually calculate and find. So let's see how to actually find that value with some actual values and numbers. So we're gonna need to find it, finding or calculating the slope. To do so, we need 2 points. We need 2 points. Let's say point A with some coordinates and another point B with also some coordinates. So last time you should have learned how to do these, how to find or plot points on a graph. So this is basically what we call a pair of points. It has 2 coordinates, x and y. This is also x and y. So to find the slope of a line that goes through these, let's say randomly, for example, A and B, there's a line that goes through those 2 points. Okay, doesn't exactly go like this, but just hypothetically speaking here. So for the line that goes through these 2 points here, we can find the slope. We can measure the steepness of this line. This is not the actual line. It's not the actual line, just a quick sketch that I did. But we're going to see later how to graph these on a graph. So we're going to need what we call the slope formula. So it's given like this. M is y2 minus y1 over x2 minus x1. That's how you mathematically measure steepness of something, any surface basically. So we need 2 points, and all these values here come from these 2 points. So the first point, we're going to call it x1, y1. Second point, we're going to call it x2 and y2. So all I have to do now is plug these here, and we'll get our slope. Could be a fraction, a negative number, a positive number. So just plug it and simplify. So for this example here, so y2, what is y2? We have all the information we need. What is y2 based on what we just did?
5.
That's right. Y2 is read from here. So 5 minus, and y1 is here, 3 over what goes here? x2 minus x1. So again, just read those from the given points. We have 1 minus, so basically y minus y and x minus x. So we get 2 here. So what we call change in y and change in x. So when you move from one point to the other, both y and x change. And this is the amount by which they change, or the rate. Simplify this, so we're going to get 2 over -1, which is -2. So that's our slope for this line. It happens to be negative. This is not the actual sketch of the line, okay? The line should actually drop from left to right, based on this value of the slope. I know for a fact that when the slope is negative, the line actually drops from left to right. If it's positive, it goes up. So our line is something like this. We're going to get into the actual line in a moment. But that's basically how you find the slope of a line. You're going to need 2 points. If you have them, simply plug them into the formula. For any 2 given points that belong to a line, you can find the slope. Let's take another example here. Let's take this point and another one. So the slope again, the formula is here. First, you want to label your points. Just call this, you can call this M1. I mean, not M1, but X1, Y1. I'm going to call this X2, Y2. Those are the values that need to go into the formula, and then we'll simplify them. So M will be, okay, what is the change here in Y? What do we subtract it at the top? Based on the
-3 minus 2.
Right, so -3 minus 2, basically y minus y. And the bottom?
2 minus -1.
That's right, 2 minus and -1. So 2, there is a minus and -1. It's important here we have a double negative. The first negative comes from the formula. The other negative comes from x1, which happens to be negative. Okay, so we have this negative here and another negative. It's a lot different from these two negatives. Then we simplify, -5. It's -5 take away 2.
-5 over 1.
I mean -5. What is this equal to? It's not 1.
That's 3, right?
It's 3.
-3.
Double negative turns into a positive, so you get 3. And that's your slope. Okay, that's the slope again. It's a line that drops from left to right. If the number here is positive, that means the line goes up. So let's do those cases here. So types of slopes. There's 4 types of them. So your line either goes up from left to right. In this case, you have a positive slope. If it drops from here, from left to right, it's a negative slope. The line could also be horizontal to the x-axis. So as you saw the other day, this is always the x-axis, this is the y-axis. If the line we're looking at is parallel or to the x-axis, what is horizontal, the slope would be 0. Okay, the slope here is exactly 0. And if the line is vertical, means it's like this, and it's parallel to the y-axis. The slope is undefined. For now, just remember those like that. Don't think about them too much. Okay, just by looking at a line now, you can at least know the sign of the slope. You could know this the slope is 0, and also you would be able to know whether the slope is defined or not. So vertical, not undefined, horizontal, 0. And these you could easily tell from left to right, either positive or a negative slope. Okay, that's why we get these numbers here. It's okay to have fractions, positive numbers, decimals, any sorts of real numbers basically that we saw can be the quantity or the value of the slope. You could also find the slope from a graph. Okay, finding the slope. You may have, let me see if I still have it here. Nope. Let me grab one of those graphing papers quickly. By the way, if you need a graphing paper for any sort of these problems, you can easily Google it. You can print it out, you can just use it, copy it, and paste it in your workspace and work with it just like this. Here's a graph. Change the size a little bit. Okay, so we have two axes here. This is always the y-axis, the vertical one. You got your x-axis here. That's an empty graph. It doesn't have anything on it. We can plug whatever you want. You can draw all sorts of, graphs of equations or functions. Let's assume maybe there's a line that goes through this. Be here and here. And so for this line, we're going to try to get the slope. So we don't have the slope. All we have is this line and some coordinates. We can actually find the slope of this line by basically getting a couple of points. So to find the slope, we need 2 points. Okay, we're going to need 0.1 and 0.2 and their coordinates. Those we can get from here. So if you look at this point, for example, this point, or any other point you want from this line, go to something that's easier to find and not a decimal or a fraction. We're going to get those coordinates and then use them here to find the slope. Luckily here, we were given the points and the coordinates, but here we don't have them. What are the coordinates of this point? Let's call this one 0.1. We're going to call this 0.2. What are the coordinates, the x and y of this point here?
Negative 6x.
That's right. So the x is on this axis. So for this point here, looks like the x is negative 6. What about the y?
0.
That's right. For the y, we're going to drop it over the y-axis. This is the y-axis. To find the y of any point, just drop it vertically over the y-axis. So you end right here on the y-axis, which is 0. So again, the x is on the x-axis. Drop it over this if it's not already there. For the y, you drop over the y-axis. Now, let's get the coordinates, the x and y of this point. Start with the x. This is the x-axis. If you drop this vertically, what is x?
0.
That's right. The x, both x and y are 0 in this intersection, so that's 4. And what is the y of this point on this y-axis? Obviously, it's right here on
4.
4. I'm sorry, this should be 0 here. So again,
I got a little mixed up myself. I'm like, wait, did we just answer that one?
That's okay. I was thinking about the other 4. So this is going to be 4. So again, to get the x, drop it over the x. So it's 0. And to get the y of any point, drop it over the y. That's the first thing you do. Now we're going to label these. Let's call this x1, y1, x2, y2. And this is what we're going to need for the formula. Again, the formula is easy, just change of in y over change in x. Which means when you go from this point to this point, both x and y change. And this is the rate of change. We go from, for example, if you move from here to here, the y went from y2 to y1, y2 to y1. So we're going to do, so y2 is 4 minus y1, which is 0. Also, the x changes. If you go, if you go from point 2 to point 1, or the other way around, if you go from this point to this point, the x will also change. The x here is 0, but the x here is -6. So 0 minus -6 minus -6. So basically x2 minus x1. Okay, just like we did earlier here. And of course, we're going to simplify this. So it's going to be 4 over negative turns into a positive. That's our slope. We can reduce it, turns into 2 over 3. As you can see, the slope is positive. So as we explained here, it goes up from from left to right. So here, actually, this confirms this what we said here. As you can see, it goes up from left to right. It does not drop, and that's why the slope is negative. If the line was, for example, like this, and you took 2 points, this will be a negative number. That's how you find the slope. Just be careful when you have a negative in the coordinates. You may have a double negative like this, so be careful with that. So you can find it using 2 points, or you can find it from a graph, which is not hard to do. Just get the coordinates of 2 points. Okay, everybody, any questions about this before we go to another section? Any questions, everyone?
No, sir.
Okay,
No, sir.
all right. So that's one way to find the slope. Another way to find the slope is easier. We can just read it from an equation. And that equation is what we mentioned earlier here, slope-intercept form. This would be number 3, I believe. 3. Oops. I'll call this a slope. This is named after the fact that it has slope and something called intercept in it. For example, m of x, mx plus b. This is the slope-intercept form. The reason we call it so because it gives us the slope, m here, so we don't have to calculate it or do this. If you have an equation like this, you can easily read the slope. So this is slope, and it says slope-intercept, and this point here, or this number here, is called the y-intercept. We're going to explain why it's called so. Okay, so the y mxb, it's called the mxb form or slope-intercept form because it clearly shows the slope and also shows the y-intercept. The slope is whatever we were talking about. It's the steepness of the line. The b is the y-intercept. It just means, this is the y, just means where the line and the y-axis meet. So this is the y-intercept here in this case. For this line, the y-intercept is where your line, whatever line you're working with, and the y-axis, not this one, they meet here, so that's called the y-intercept. So B here is the y-intercept. See a couple of examples here. Find y, not y, find m and the y-intercept. Okay, the y-intercept as in here. All right, so that's our line. Find the slope. Again, no need for 2 points because we have the equation itself. What is the slope here? Slope m is, what is the slope based on this formula and this?
2x, 2.
Just the 2, okay? Just the 2 itself and the number next to the x. So the number next to the x here is 2. And what is the b or y-intercept?
1.
1, better yet,
Oh, -1. Wait.
negative 1. Negative 1, that's important. So that's why we call the y-intercept. So for this line, for this equation, the line and the y-axis, they meet here at -1, not 1. 1 would be here positive, but they meet here. Whatever the line might be, we're going to see how to find it specifically. So those two meet over here. Okay, so those two, they meet over here. So the line is probably something like this. So this is the that y-intercept. It's right here at -1. The line you're working with and the y-intercept. That's why it's called y-intercept. It's the y-axis and the line. That's where that point is. And you can easily, like I said, read that from an equation when it's given to you. Let's do another one here. Let's say, okay, what is the slope here? The slope or the number next to the x is this one here, so m is 3/5. And of course, the or y-intercept is 2. Sometimes the equation can be, let's say we have 4x minus 2y is 6. So in this equation, we can't tell what's the slope yet because it's not in this form. It has to be in this form, meaning the y must be by itself and everything else on the other side. So we're going to do some changes here first to turn this to look like this. Once we do that, we can easily read the m and b. Let's make this a positive here. So first thing you want to do is get rid of that term with the x, move it to the other side. So we want to keep the y on one side, just like here. So this is a positive y, so it stays here. When you move 4x to the other side, it's going to turn into -4x and plus 6. We're almost there yet. We need to get the y by itself. So we're going to divide the entire equation by 2 because we want to get rid of these two. So y is -2x plus 3. Now this is slope-intercept form. Okay, when you have the y by itself, like we said here, this is what we call the slope-intercept form, is when the y is by itself, no number or sign, and the other stuff is on the other side. Okay, now if you look at this equation, what is the slope m? What's the slope of this equation now? Just like we've been doing.
Slope is 2 and the intercept is 3.
That's right. The x is the slope is -2. Okay, the number that's next to the x. Obviously, that's a negative slope, so the line drops from left to right. and this is the y-intercept, or b. Okay, we couldn't tell from here because this is standard form, what we call standard form, not the slope form, slope-intercept form. Okay, so we cannot tell the slope from here until we change this into that. Once we do, then we can read our slope and our y-intercept. One more example here. Here's another example. What is the slope here? What's the slope of this line here? In other words, what number is next to the x, to the left, next to x? Well, what is the coefficient of x? What number is multiplied by x here? There's an invisible -1, okay, x. So again, slope is whatever number is next to the x. Could be an invisible one or an invisible -1. Could be a positive number or a negative number. In this case, it's an invisible -1. And of course, the b is 4. Okay, it's very simple. You can just read that from the equations. So the next thing we're going to talk about is we're going to see how to graph these lines. So far we can get the m, can get a p, but let's see how to get the graph from here quickly. So graphing lines using the slope-intercept form. It's very quick, very easy. Let me take one of the examples. Okay, so that's the equation. We want to graph it, so we're going to need a graph right here. So here's what you do. You can graph this very quickly in seconds. So last time, I believe to graph, you did table, x and y, plug some values here, and you get a bunch of points, and then you plug those points in the graph. That's what I was taught last time. Today, instead of doing a table and solving and plugging, we're not going to do anything. This formula is convenient. It allows us to immediately put the line on the graph in a couple of steps. So we're not going to do the table. The table, you do that when you have the standard formula. If you have a standard form, you can use the table to graph it. But if it's in this form, YMX form, it's convenient and quick to do it without the table. What does this represent again? The positive one, what is it called? Well, first, let's start with the m. What is the slope? Everybody, what is the slope of this line?
2.
Not just 2, but 2
over 3.
over 3. So the whole number next to the x is the slope. And this again, we call this b, or y-intercept. Y-intercept is 1. And the reason again we call it y-intercept is because it's on the y-axis. And that's where the y-axis here meets our line when we find it. So they will meet here. So to graph this, it's very simple. First, you gotta start from here. Locate this on the y-axis. So it's right here. And then we need to go from this point to the other point of the line before we can draw a line through them. And to get there, we do what we call a rise and run. So the slope is 2 over 3, which is also called the rise and run. The top number is the rise, the bottom one is the run. The reason why we say so is we start from here, which is here, and then we rise or go up 2 units. So from here, we're gonna go up 2 units. And the run is either left or right. So again, rise. So the rise, you either go up or down, depending on the sign of this number. If it's positive, you go up. If it's negative, you go down. For the run, it's not vertical, it's horizontal. You either go right or left. Again, for positive or negative. Up for positive, down for negative. Let's see how that works in the graph. So you're gonna start from here, +1, which is here. Then we're gonna go up. So the rise is positive, so we're gonna go up 2 units from this, 1 and 2. Once you get to that unit, you either go left or right based on the sign. In this case, do we go right or left with the 3? Look at the run, look at its sign and tell me whether to go right or left from here.
Right.
That's right, we go right. So start from here, go up 2, and then to the right. Because it's positive, we go to the right 3 units. So from here, we're gonna go 1, 2, then to the right 3 units, 1, 2, and 3. Then we end right over here. And that's it. Those are the lines we need, and you just draw a line through them. So you do this fast without, doing any actual math. Just start from here, rise or run, and you get your line. So let me grab a line, straight line. Usually you would grab your ruler at this point and just draw your line through those 2 points. Okay, the first one and the second one. So again, the rise and the run. So this is what we called earlier the change in y. So this is the rise. Then you have the run. This is a run, which is vertical. So you rise up or down, you run left or right, depending on the signs of the numbers. And as you can see, we went up, then this, and we end on this point. And we have our line drawn quickly without having to do any math or fill up any table or complete ordered pairs. We can do that right away. Let's switch things up a little bit. Here's another example, same thing. We want to put this on a graph quickly. Let me first paste. All right, if you look at this line now. Okay, so let's grab it. So where do you start from? Where do we start from to graph the line? If we follow the same steps as the previous.
The line, right?
That again? I'm sorry, repeat that.
And then it'll be at
What's the starting point?
-2.
That's right, -2. So you start from the y-intercept. That's your first point, you just mark it. Again, it's got to be on the y-axis. So it's this one here. That's good, that's 1 point. How do we get to the second point? So we need the slope, right? We need the rise on the
-3/1, right? For the
exactly, -3/1. So we have the rise, we don't see the run, but we can turn any number, that's the slope, but we can turn it into fraction simply by adding 1. That way we have a rise on the run. So if you don't have the run, simple, just add 1. Okay, so we got the y-intercept. Now we want to go to the second point using these. So how do you get from the y-intercept to the other point using this? So where exactly do you go from here? Start with the rise. Which way do we go and how many units?
I mean, you go up 3 and over 1.
So the rise is the top number, and we say we go up or down depending on the sign. So which way are we going here?
It's down. I'm sorry.
That's right, it's down. If it's negative, you're going down. If it's positive, you go up. So from here, we're going to go up down 3 units. 1, 2, 3. And from there, the run, are we going left or right? From right here.
Right.
So right, how many units?
1.
1 unit, exactly. Again, we started from here. We went down 3, not up because it's negative. Then for the run, we went to the right instead of left because this is positive. And that's how quick it is to graph your line using the slope-intercept form. One thing left to do is to join these two together. It has to go exactly through those two lines. So let me try again. So again, you'll be using a ruler for this, so it's easier. So something like this. Okay, so the line again has to go through those 2 points like so. And that is basically all about the slope here. As you can see, it's useful. We can find it. We can at least see we'll determine the sign of the slope at least immediately just by looking at the line. You can also use it in this form of horizontal run to graph lines. As we said earlier, see this one goes up from left to right, goes up from left to right. That's why the slope here is positive. However, this one has a negative slope, so it drops from left to right. So this confirms what we've been talking about earlier. And that's pretty much how you graph your lines using the slope-intercept form. Any questions, any issues about this, everybody?
No, sir.
Okay, everybody else? That's okay? All right, so let me do one more problem, one more example like this for you. Change things a little bit. If we do this, okay, let's try to grab this one. Again, a couple steps. What do you do? Okay, let's grab this right away. Where do we start from again?
Well, the slope would be 3 over -4. And the y-intercept would be 2.
That's right. Where do we start on the graph?
Start on the y-axis.
That's right, which is 2. So start from this point, locate it right here. From here, where do you go? So from here, where do you go?
2 is your intercept.
2 is the y-intercept, that's right. So we're here now. We want to get to the other point using the slope. So what do you do?
You rise 3 and then go. So you go up 3 and then you go left 4.
Exactly. So we're going to rise 3 and go left 4 from the y-intercept, which is this 1, 2, 3, and then 1, 2, 3, 4 to the left. And that's basically it. You can do this literally in 3 seconds. And we just need to join these together. And our line is done. Okay, so that's the graph of this line. So the question may say graph this, that's done. Or it may say just what is the slope? You say the slope is this. Or it may say what is the y-intercept? You say this. So just answer it accordingly. So the m, if asked, is 3 over -4. Doesn't matter where the negative goes, and the b is 2. The question could be as simple as just what is the slope? You write this and you're done. If it says graphing, then you do this. So it's pretty simple. And that pretty much concludes the lecture for today about the slopes, rise and run. And in the next class, there's going to be, going to talk more about slope, the slope-intercept form. Next class, we're going to see how to write our actual equations. So this will not be given to us. Something else will be given to us, like a graph or a couple of points. Point 1 and 2, and we're going to see how to use that to write our own equations. We're going to come up with them and write the equations for the lines using the slope-intercept form, or even using other formulas that derive from the slope form. Okay, so we're still going to be using this quite often in the future classes. Let's see, any questions, everybody, before I give you a couple of practice problems? Any questions, any issues, everybody?
No, sir.
Okay. All right, I'll give you a couple of practice here, just like before you can do on your own. First, find slope. Using, for example, 3 and 1, 7 and 2. First case, second case, maybe 5, -2, -4, and 3. And the next one. So here you just need to find the slope, like I said, and say maybe 3x here, 6x plus 3y. And 9, so find the slope. Next one is to graph. Actually, we make this one -2. Okay, these graph, same way we just did. This, you just need to find the slope. You don't need to graph them. I'll give you a few minutes to work on this. So have some time, give you about 10 or 15 minutes. So check back with you when you're done. Everybody, are you finished?
Yes, Professor.
Okay, everybody else, can we get started? All right, for the first one here, what is m? 2 minus 1, 7 minus 3, that's 4. Okay, you guys got it?
Yes, Professor.
So second one, 3 minus minus 2, that's
1,
minus minus turns into a plus, so it'll be
5,
5, right? Then you have negative 4 minus 5, which is
9,
9, right? What's the slope of this equation? What is the slope?
2,
No, there is an invisible one here, so the slope is
1/2.
1/2. Can we read the slope from here right away? Do we know it? So we don't know the slope yet. It has to be like this. The y must be by itself, so you gotta move this over. So this would be 3y. 6 over moves to the 6x, moves over, becomes negative 6x. Plus 9. Then get rid of the 3, but you gotta divide the entire equation. So y will be the y will be negative 2x plus 3. What is the slope now? From this equation, we can easily read the slope. What is it? It's right here, negative 2. Negative 2 or negative 2 over 1 if you want to graph it. But it's the same thing. Now let's do some graphs. So we have line 1, line 2, line 3. We can do those all in the same graph to save paper and the trees virtually. Okay, so line 1. So someone tell us the 2 steps here quickly. Who had to start and where'd you go? Everybody, how do I graph this line?
The y, and we would start with the y intercept, y axis.
Which is here, and then?
Then we would go up 3 and to the right 4.
1, 2, 3, 4. That's right. That's our first line. Let's do the other one in a different color. Line 1, line 2. We're going to start from 3, which is here. And then
Go up 2 and to the right 1.
not up, but it's negative.
Down, sorry.
1, 2. Then to the right once. Okay, and the last line here. What's the slope for a rise over 1? Be 1 over 1, okay, invisible 1 there. So
We would start at negative 4, and then we would go up 1 and then to the right 1.
that's right, just like that. So these are all lines. We can go ahead and join them. So let's say first one is here. And second one would be this. And finally, some other line. Will be this one with the green points. And that's pretty much how we graph lines quickly using the X and Y intercepts. It's convenient. We got line 1 here, line 2, and finally line 3. Okay, everybody else, you got this? Any questions?